Okay, first of all, announcement time. The LDOC is Tuesday, April 26th. Therefore, your last day is Tuesday, April 26th. I have to do that. Yeah.
Why is there so much hand holding here?
I don't know.
Okay. Two things will happen on the 26th. One, all homework will terminate at midnight or 11:59 p.m. April 26th, the last day of class. So, last day of class is Tuesday, April 26th. Therefore, your last day is April 26th. On the 26th, the homework will terminate April 26th, the last day of class. Okay, y'all see a pattern? Second thing that will happen on April 26th is the final exam online and the last test. Material I cover up to the 26th, which is not going to be much. Final exam online and the last test will start on Tuesday, April 26th, the last day of class. Okay? All right. I have been known to open up what? Y'all okay back there? Are y'all on drugs? That's from my cousin Vinny. Are you on drugs? No, I don't take drugs. I have been known to open up past assignments for a period of time for students to catch up. If you see this on MyLab Plus, do not call me and ask what do I do Let me ask you a question. If I gave you your test back and you're looking at your test and you made a 75 on the test, but I accidentally put a 95 on your test, would you come up to me and say, Hubert, you accidentally added 20 points to my test grade?
No.
If you are, you're an idiot, okay? If I open up the assignments, past assignments, on My Labs Plus, are you going to call me and ask me, I thought it was due like 3 weeks ago? No. What are you going to do? You're going to take advantage of it. Yes, I had students call me, text me. The Unit 1 material is opened up till the last day of class. What are we supposed to do? Did I answer?
No.
No, I did not. And I hung up. I didn't hang up. I'm going to say, I'm going to let you figure that out. And I hung up. And these people procreate. All right. Let's see if there's anything else. Oh, yeah. I have. What? A picture of what? Okay. I have to give an in-class final. Hold on a second. Go to your handy-dandy Tri-County Tech page. Go under Message Center. Is everybody listening? Go to Exam Schedule. Find your class at the Anderson campus. We meet on Tuesday and Thursday at 11:10. So there is your exam day. Write that down. Thursday 28th, 10 to 12. Thursday the 28th from 10 to 12. Just let me finish talking and I'll tell you what we're going to be doing. Thursday. I forgot. April what? 28th. From 10 to 12. What classroom is this? AC. Is it 225 or 224? 225. I will be giving an exam in class. Okay? It's going to be so detrimentally hard, you're not going to be able to take it. Okay? I made a face, okay? So it's going to be very, very difficult. I don't even think you're going to be able to pass it. Okay? Probably going to be on the board. The test questions are going to be on the board. I'm not going to copy all these pages, and I'm not going to do all this work that they're trying to get us to do. I'm not going to do it. So, and it will be a quiz grade, okay, which will go into your test grade. Not as much as a test because it's, okay. So those 5 questions will help you grade out a little bit. Okay, who's got questions about the last week of class? Oh, during the week of finals, I will be finalizing. I don't know how to spell finalizing. Huh? That don't look right. I will be finalizing your grades in reference to bonus points and corrections. Stuff like that. So you're going to see your grade kind of fluctuate a little bit, probably in the middle of the week, because I'm going to put bonuses in. I'll probably put your final exam in. The in-class final exam I have to put in. I'll put that in. And you might see probably going to see your grade go up a little bit. So if you look at if you look at your grade one day and it's 89, and then you look at it the next day and it might be a 91, that's why. I'm sorry, what'd you say?
Are you going to be fixing like a mileage test thing or whatever?
Am I going to fix them? What do you mean fix them?
Like some of those I haven't answered right now. Like
You need to see me about those,
Okay.
because I can't go through and check every one. So any answers that you need me to check, see me during the week of finals. I'll be in my office all week pretty much. So just come by there and I'll fix them.
But we can't get back in and write it down.
What do you mean?
Like, look back at the 10. That's how I look back at like 10, so I can write it down or walk alone.
You can't under grade book. You go under grade book
Okay,
and hit review,
okay.
and you can go in and look
All
at
right,
it.
okay.
If not, let me know and I'll fix it to where you can. It should be. Okay. I will be finalizing your grades in reference to bonus points, corrections. That'll be corrections like grade corrections, like just like you said. I'll say test, answer, corrections, meaning that you put an answer in the test and the test didn't like it because you put 0.5 and the test wanted 1/2 or something like that. So that's the week you need to see me. I will be in my office pretty much till 1 or 2 every day. Okay, pretty much. All right, who's got questions on any of that? A lot of people say, when you going to open up all the assignments? Well, I'll do that when I want to do it. Okay, I'm not going to give you a day that it's going to open and a day that's going to close, because half of y'all are going to wait till the last day to do anything. If I open it up on the 5th and close it on the 10th, y'all are going to wait till the 9th. So I'm not going to do that. I'm just going to open it up. When you see it, you take advantage of it. Okay? Any other questions about the last week of class? All right, now, I know y'all got it counted down to like the minutes and seconds, but the only section I haven't covered in this class is the section on systems of equations. And what I will do, and I'm going to put that on here too. Somebody tell me what chapter that is. Systems of equations is the last unit. And out of that unit, I will cover, within the next 2 or 3 days, I'm going to cover graphing, elimination, which you already know, graphing, elimination, and substitution, because that's taught in most algebra classes, high school algebra classes. And then I'm going to add matrices. Okay? I could really cover this first part, these 3 right here, I can cover in one class, and then spend the rest of our time on this. I think it's kind of nice to be able to deal with matrices. So, you know, at least for some of you people that are going into computer programming or linear equations, which is nothing but computer programming, you might, you know, get a little bit of information out of that section right there. So I will cover from today until April 26th. I will be covering this material. Now, if I cover only 2 of those sections, then that's what you're responsible for on the last test. If I cover all 4 of them, then you're responsible for all 4 of them. But I'm not going over that. That's it. I don't know. What chapter is it? Did anybody look it up in your syllabus? Should be unit, I think it's unit 3. I skipped it, I think. It says solving systems of equations. Does it say it on there? Let me see. Here it is, solving systems of equations. Chapter 6. 6.1, 5, 6.1, 5, and 8. 6.1, 6.5, and 6.8. 6.1, 6.5, 6.8. I think 6.1 and 6.5 is pretty much all of this. And then they got another one that says partial fractions. Partial fractions we use in Calc 1, no, Calc 2. You see a little bit of it in Calc 1, but you see a good bit of it in Calc 2. There's a whole unit, a section, yeah, a whole section that's on partial fractions. So that's what I'm going to do this next week, or whatever, how many days y'all meet. Y'all got it 3 or 2 or whatever. Okay, any questions about the last few weeks of school? There it is. So if you need to take a picture of it, take a picture of it so you'll have it. And I won't have to listen to any DA questions these next 3 weeks. Well, I mean, after I go over it, I shouldn't have a question on it unless it's a question in detail. I mean, you shouldn't be coming up to me and asking me when's the final exam. Okay? I'm not going to tell you that. I'm not going to repeat myself 25 times. All right. Has anybody got any questions about the last homework or last test? Everybody seems to be okay with that. Let's look at it and see how let's see, where's the test? Chapter 3, what was the last chapter? Logs. Let's see what the class average is. Well, I got to put the zeros in, but let's see. Class average on the log test is 82, but that's with a lot of zeros. Let's go ahead and put the zeros in so we can make people's grade go down. Always like to make people's grade go down. It's closer to that cardboard box, isn't it? Huh? Closer to that ditch. Huh? Oh, I got several ditches. I got several ditches out on the farm that y'all can live in. Got rocks that y'all can lay on and overhangs, you know, keep you out of the weather for a little bit. I got all kinds of places that y'all can live in. Let's try that again. Okay. Not supposed to do that. There we go. There, now, the class average now is 70. And there's your grades. So it's not too bad. A lot of B's, looks like a lot of A's and B's. And then there's the alternatives.
Is that 22.85?
Oh yeah, 22.85. There's probably some 5s up there and some 6s and some. Of course, remember, how many bonus questions do you have? There's like 10 on each test. So everybody should be making a 40. At least a 40 or a 50, you know? And there's plenty of zeros and 26s and yep. So that's the average. The average is there.
Oh wait, so that's like the overall average?
No, the class. So 70 average. So if you want to know how well you did in the class, compare it to a 70. That's how you did.
No, I mean like our overall grade.
I'm not going to show you overall grade because I'm not showing the names. If I showed the names, I'd have somebody. So that's why I'm not showing the grades. I'm showing the names.
Well, it's my last name.
Yeah, but you don't know everybody's last name in here. You don't know. There, find yours now.
I know what my grade is.
Good. Oh, good. You're cognitive. That's good. I'm glad. You're not one of these people that, can you tell me how to find my grade in class? Yeah, walk straight ahead, right out there in the middle of 28, right out there. Idiot. Okay, so let's get started on solving systems of equations. Now, like I said, some of y'all have seen this before, some of you have not. So I'm going to assume that some of y'all have not seen it.
Right, period, when you pass assignments and period.
That means everything. All right, that doesn't look right. That's because it's not the right one. There we go. Now, solving systems of equations means that we're going to find the answer to a system of equations. And a system of equations means more than one equation. A system of equations means more than one equation. More than one equation. Most of you are used to seeing this like so. 2x plus 3y is equal to 6. And 2x plus 4y is equal to 8. You've got two equations and how many unknowns? 2. So it's solvable. 3 equations, 3 unknowns. 4 equations, 4 unknowns. One of the questions on my surveying exam was dealing with GPS and why do we have to have 4 satellites on each GPS signal? Anybody want to take an example of that or take a stab at it? Because there's 4 variables. X, Y, Z. And what's the 4th variable? The one that nobody can mess with. Time. Parametric equation. Okay? And you have to solve 4 equations, 4 unknowns, or you have to solve for 3 equations given the fourth, which is time that it takes a beam to hit from the satellite down to the GPS receiver. You got that time, you can solve the others, and you can check between the 4 satellites. That's why you have to have 4, because of 4 unknowns. Anyway, to make a long story short, we want to find out what number works in both of these equations for x and y. Now, to do this, we have 4, 5, 6 different ways. One is to graph and see where it intersects. Okay? That's one way. Graph it, graph both of them, and see where they intersect. The second way is by elimination or substitution. Third is by elimination. And then, of course, the fourth is by linear expressions or linear equations or linear systems where you have to use matrices, Cramer's rule, anything like that, identity matrix, anything like that. All right? And we'll get into that later. So, first of all, you need to graph it. Now, the least favorable way is to graph, because a lot of people don't walk around with graph paper, in their pocket, and you don't walk around with a straight edge. You do. It's called your debit card, but you can use it. But the whole point is, it's the least accurate, because sometimes you don't hit, in real life, you don't hit on the little four corners of the graph. So sometimes you're going to hit the middle of the graph or the middle of the little box, and that's a fraction, and then y'all go ballistic because it's a fraction and end up in a ditch. So how do you graph these two? Well, first of all, you have to solve for y. So go ahead and solve both of them for y. We're going to graph these two. Now, I'm not going to go over the three methods of graphing, okay? I'm not going to go over that. If you need to go over that, you need to, you're in college algebra, which is like algebra 3. You should know how to graph those two graphs. First of all, you solve for y. So 2x plus 3y, you actually could solve, you actually could graph it with the intercept method, but if I do that, half of y'all are going to go ballistic, so I'm not even going to do that. So 2x or 3y is equal to negative 2x plus 6 divided by 3, divided by 3, divided by 3, and y is equal to negative 2/3 x plus 2. There's one line, and then 2x plus 4y is equal to 8. 4y is equal to negative 2x plus 8 divided by 4, and y is equal to negative 1/2 x plus 2. So now we're going to graph those two. You have to have some graph paper. So in order for us to do this, we're going to have to pull up some graph paper. Those of you that have some graph paper or draw some kind of graph on your notes with a straight edge, driver's license or whatever you got, it's got a straight edge. You're going to have to do it somewhat accurate, because you're not going to hit it right if you don't. So I'm going to go to a handy dandy World Wide Web and pull up graph online. I'll just do graph paper and hit images. Where's the one I use all the time? There it is. Put my handy dandy snippet tool. Save. So I'll pull up my handy dandy graph paper. And I'm going to plot me some points. First of all, my y-intercept for my first line, we'll do this one in red, is 2. So I'm going to put my y-intercept at 2 right there. And I'm going to go in a negative direction. So that means that my slope is negative. I do this in real light red. I'd rather do it in this pink. So I got a line going like that. And then 2/3. I take my handy dandy dots and I'm going to go 2 up. 1, 2. Trace line is this way. So 1, 2, 3. Go up 2, 1, 2, 1, 2, 3. Just so happens that my pink line is real close to it. Go down 2, 1, 2, 1, 2, 3. Down 2, 1, 2, 3. Now the reason I picked this method is this is the method that 90% of y'all know how to do, because the high schools teach this method because it has no math involved. That's why they teach it. So that's why I know that most of y'all know how to do this method. So now I'm going to take my black line or my red line, and I'm going to connect the what? Connect the dots. And of course you can extend it. You need to extend it. Now of course mine is a little bit off because I use those big red dots, but I did that so y'all can see it, not so y'all can complain about it. All right, there's the red line. So now we're going to do this line, and we'll do it in blue. Oh my, same y-intercept. Chances are that's going to be your intersection. So there's the blue line. Now I'm going to plot my points. Negative, again, it's going, we've already got the red line as a what? As a trace line, so we can use it. So go up 1 over what? 2. Go up 1 over, see now it's going to get confusing because I'm in the, I wasn't supposed to do that. Up 1 over 2, that one's not right, hold on. Up 1 over 2, right there. Up 1 over 2. Up 1 over 2. Up 1 over 2. The reason I'm plotting so many points is so you can actually see that it's not the same line. Down 1 over 2. Down 1 over 2. Down 1 over 2. And you can see that the blue line is not the same, but you can also see that it's crossing at where I said it was going to cross. And that is what? 0, what? 2. It's actually crossing somewhere right in here. But the whole point is we're going to find out where that point is. See, and that's why I say graphing is the least what? It's the least accurate. So on the test, I might give you one graphing problem, but I'm not going to give you too many because I don't want you to waste time graphing. I want you to know about it, but I don't want you to waste time on it because you can see you have to have a, now if you had a big old graph the size of the screen or about half the size of your paper and you had graph paper, then you might be able to find out where it actually crosses. But we don't know because you can't see. I think it's 0, 2 because that's the y-intercept. But we're going to find out. The next system, the next way, we're going to find out because it doesn't rely on a visual observation. It relies on the mathematics. So let's go to the second method, and that is substitution. Now, with substitution, I think it was 2x plus 3y is equal to 6, right? 2x plus 3y is equal to 6. And what was the other one? 2x plus 4y is equal to 8. This one, you're going to use substitution. You got to solve for one of the variables. Doesn't matter. Doesn't matter. You can solve. You got 4 variables up there. You can solve for. I don't care. I'm going to solve for x. So 2x is equal to negative 3y plus 6. Divide by 2, divide by 2, divide by 2. X is equal to negative 3/2 y plus what? 3. And I'm going to take my handy dandy blue and I'm going to write this right here in blue. Negative, you might want to highlight it, 3/2 y plus 3. And I'm even going to put a little cloud around it. Because once I solve for a variable, I can take that little blue cloud and plug it in to the other equation for what? For x. and that's called substitution. So now I'm going to rewrite my other variable, other equation. Instead of x, I'm going to put a big set of parentheses. Those parentheses are going to be blue. So this should be highlighted or drawn a circle around it. This should be highlighted, and this right here should be highlighted because you're going to take that and stick it in there. It's called substitution. So, negative 3/2 y plus 3. Now I want you to finish it. Because that's algebra 1 right there. So, what happens to the 2's? They cancel and you get negative what? 3y plus 6 plus 4y is equal to 8. And negative 3y plus 4y is y. Yeah, 1y. And then 6 from 8 is what? 2. So y is equal to 2. So now we take y and we BS our way back. BS means back substitute. Foul-mouthed people. Okay? So take that 2 and plug it in for y, or substitute it in for y. So x is equal to negative 3 over 2 parentheses plus 3. I think you're going to get 0. X is equal to what?
0.
So I was correct. 0, 2 is the intersection of these two equations, which is the intersection. But it's also the solution to the system of equations. What does that mean? That means if I plug 0 and 2 for x and y into this equation, what am I going to get? 6 is equal to what? 6, Hubert. That's right. It's going to be a true statement. If I plug in 0 and 2 in this equation, what am I going to get? 8 is equal to what? 8. No matter what. So these two numbers are the only two numbers that will work in what? In both equations. Very hard to find a number that'll work in both equations. If you can't find one, that means they're either parallel or they're the same line. Parallel means what? That there's no solution. They never what? Parallel lines never what? They never intersect. So there means no solution. So you need to write that down. Just put two lines that look like a slanted 11, which means parallel. Parallel equals no solution. I think parallel has 2 R's and 2 L's, 3 L's. It's one of those words it's hard for me to, anything with necessary. I just put needed. I don't put necessary, I put needed. I cannot spell necessary. The only word I can decently spell is Mississippi. That's the only word. Necessary, you can forget it. Assess and access, that I can do those 2 words. But you give me 2 or 3, oh gosh. Parallel, P-A-R-R-E-L-L-E-L.
It's 1 R.
It's 1 R?
Pretty sure.
See, I got it wrong. I don't know what it is about all these different. I suck. All right. So, what about the same line? If it's the same line, if it lays on top of each other, then it's infinite solutions. That means each point crosses the other. I mean, laying on top of each other. Infinite solutions. I'll try not to give you those 2, but if they do, then they're easy. You don't have to do any math. You just say no solution or all real numbers or infinite solutions. All right, let's do a nerd. I'll make this one easy for you. This is one type question you're going to see. Given 2 like this, here's another type. This one you'll like. Y is equal to 3x minus 2. Two x plus 4y is equal to 12. Why do you like this one? Because you don't have to do any work. You just have to plug and chug. You don't have to solve for y. Well, I really don't want to solve for y. I'd like to solve for x. You're weird. Take the y, put parentheses around it, plug it in for x, or plug it for y, sorry. So that means I'm going to take my handy dandy blue pen and I'm going to draw my little cloud, or you highlight it. And then I'm going to take this equation to my blue parentheses plus 4y is equal to 12. And then my 3x minus 2 goes in right here. Now, if you ever want to know what part of algebra I love, that's this section right here. Yes, sir? Yeah, you're right. Sorry. I was in last. No, you're right. Thank you. It's all right. You're just going to fail. That's all. You had an A up till today, bud. That's all right. You want to make me look bad? That's fine. I just showed the class the wrong way to do it, and you make me look bad. That's fine. Parentheses equals 12. And then when I got to matrices, oh man, I love matrices. So I'm going to plug in 3x minus 2 after I was rudely reminded that I did something wrong. 2x, what's 4 times 3? 12x minus 8 equals 12. 14x. 14x is 20. You're right. Thank you. Y'all can slow down a minute. It's all right. He'll slow down in a few minutes. X is equal to 10/7. Back substitute. Three over 1 times 10 over 7 minus 14 over 7. Thirty over 7 minus 14 over 7. Dang old 16 over 7. So these two intersect at 10/7 and 16/7. And then of course if you wanted to picture it, you would say 1 3/7, which is 1 1/2, and then 16/7, which is 2 and what? 2 and 2/7, which is, yeah, about 1/3. 2/6 would be 1/3. So that's where it crosses. And that's the substitution method.
So this is chapter 6.
Hold on a minute. Hold on. Systems of equations is the last unit, 6.1, 6.5, 6.8.
This is it?
From today until April 26th, we're going to cover graphing, substitution, elimination, matrices, and partial fractions. Okay, what was your question?
Like, it's easy.
Okay. It's easy. Okay. Elimination. I'm sure everybody in here says, yeah, it's easy. What about the person that's sitting here going, I've never seen this before? What about that person? You don't care about that person?
It will be easy.
Okay, there you go. Good answer. Good answer.
Yes, sir.
Okay, be quiet. All right, next one. Elimination. Elimination 1. Look for different signs. 2. Look for equal coefficients. 3. If not, 1 or 2, as Jean-Luc would say, make it so. And that's elimination. Elimination. Supposed to be D. Anyway. So, what does all this mean? Well, just write it down first, and I'll show you what it means. Look for different signs. You got two equations, and usually they put them on top of each other. 2x plus 3y, and then whatever plus blah, blah, blah. They put them on top of each other. You look at the columns. The 2's are the coefficients, the x's, and the coefficients and the y's. You're looking for opposite signs, and you're looking for the same coefficients. That's the two things you're looking for. If you abide by the KISS method, which is keep it what? Keep it simple. Now, if you want whips and chains, then you go through and you change all of them. You can do that. If you like extra work and extra pain, then you can do that. But I'm trying to show you the easiest way to confront one of these problems with elimination, because you're trying to eliminate a variable. That's why it's called elimination. Now, pay very close attention to what I do here, because this goes into the matrices, the ones that probably you haven't seen before. This one is one that people have not seen before, because teachers don't like to teach it, because you have to think. Yeah, and high school teachers don't like to teach this because it's kind of like completing a square. You have to use those fractions. Well, they don't like to teach this because you actually have to think. All right? So, they want you to read your tape. So let's take that first example, and I'm just going to modify it a little bit. 2x plus 3y is equal to 6. And then I'm going to put a negative 2x plus 6y is equal to 12. All right, now, of course, the directions say use elimination. If the directions tell you to use graphing, you use graphing. If they tell you to use elimination, you use elimination. If they tell you to use substitution, you use substitution. But if they just tell you to solve, then you can use what? Any one you want. Okay? So, this one's going to say solve elimination. First thing you automatically pick up on is what? This is a positive, and this is a what? Negative. That's the first thing you should zero in on that. Then you see what? You've got what? Not only positive and negative, but you've got the same what? Coefficient. This is easy, right? So, with elimination, I can take out this first column right here. All I have to do is put a plus sign right here. Put a line there. Now I'm showing you the easiest one first. What do I already have? I have opposite signs and I have the same one. Coefficients. Are they all going to be like this? No. So if I take 2x and I subtract 2x, that leaves me with what? 0. So this goes out. And that's what you're wanting to do. But if you add this, you got to add what? The rest of it. So what's 3y plus 6y? And 6 plus 12? 18. And y is equal to 2. Now you can back substitute either one, whichever one you want. So 2 times x is plus 3 times 2 is equal to 6. 2x plus 6 is equal to 6, and x is equal to 6. Okay? And that's how you do elimination. But that's the first type of elimination. I'll give you another problem. Negative 2x plus 6y is equal to 12. And negative 2x plus 4y is equal to 8. Okay, do that one. You ain't got opposite signs. So what do? Erase one of them? Or quit? Quit. Throw your pencil down and quit. Nope. You multiply one of them by a -1. So, since we're going to subtract or add this way, I'm just going to make this one negative. So I'm going to take my handy dandy blue marker. I'm going to multiply this one by -1. Why am I multiplying it by -1? Because I want the 2's to what?
Well, Hubert, I don't like to get rid of X's, I like to get rid of Y's.
Well, you can multiply this by -6. Or, -6 and multiply this by positive what? 4. Whoops, change. Knock yourself out. Because you're going to make everything else what? Bigger. By multiplying this by 6 and multiply this by -4, multiplying this by +4, multiplying this by -6. However you do it, you're just going to make these numbers what? Bigger. So I got that negative makes this a positive 2x, makes this a negative 4y, and makes this a -8. And once I multiply that through, my parentheses go away. And now I put my line under it. And the first one goes out. 6y minus 4y is 2y, and 12 minus 8, and y is equal to 2, and then back substitute to find your x. So back substitute negative 2x plus 12 is equal to 12, x is equal to 0. These are just coincidences. They're all coming out to be 0 and 2. I'm just making them up as I go. Now the third one is the one that's more difficult out of the elimination. I'll just throw some numbers up here. 2x minus 7y is equal to 14, and 6x minus 4y is equal to 24. All right, do that one. Now this is the one where you have to make it so. You have to make it work. Yeah, just get up and leave. That's fine. Whatever.
Okay.
Now I'm going to stick with what we've been doing. I'm going to get rid of the x's. There's no special reason. The numbers may be a little bit smaller because when you multiply that bottom one by 7, if you want to get rid of the y's, you're going to make the 24 big by multiplying by 7. So I'm just going to multiply the top. And you don't have to do it this way. There's 2 different ways to do it. There's actually 4 different ways to do it. I'm going to multiply the top by 3. And multiply by negative, so it will make this go out. So I'm not only multiplying by a sign, I'm multiplying by a coefficient also. So I can make this one go out. So when I do that, I get negative 6x plus what? 21y minus what? 42. And what happens to the 6x's? They go out. Negative 4 plus 21 is 17. 24 minus 42, what? I didn't hear you. You didn't enunciate. Speak up. 18. Thank you. Be a negative 18. And y is equal to negative 18/17, which is a little bit over 1, negative 1. And then take that and back substitute. Now, all of this is review. We just had a review over Algebra 1 and Algebra 2. What are we heading toward? We're heading toward matrices. I'm going to give you one example of a matrix before we, I don't even know what time we finish. What, 12:20? 12:30? Huh? Okay, well, 12:30. We'll finish here in just a few minutes. Because the matrices is nothing but what we've been doing in a easier fashion. Okay? So your homework tonight is to go over 6.1 and just do the questions that ask you about graphing, substitution, elimination. I don't even know if they have matrices in this chapter, but we're going over it. So, matrix. A matrix is I guess you would call it a representation of system of equations without, that's supposed to be without, the variables. Example, 2x plus 3y is equal to 21. No, 24. And 4x minus 5y is equal to 20. That one is how you write it in graphing, substitution, elimination. But with a matrix, you change it into a, and I'm just going to do this thing don't dot very well. An X column, a Y column, and I call it solution column. And in this column, we're going to put 2, 4, 3, negative 5, 24, and 20. Put it in parentheses, put a line right there, and that's the matrix. Now, this you don't see. It's just assumed. This is the X column, this is the Y column, this is the solution. Call it the solution, the product, whatever you want to call this column. It's what's on the right side of what? The equal sign. This is the equal sign right here. Now, there's all kinds of things we can do with, we can find the identity matrix. We can use Cramer's rule. We can extend the matrix. We can do all kinds of things with a matrix. I'm just going to show you 2 things, all right? Not today, but I'm going to just give you an example of something we can do, and you don't have to write this down, you can just watch, all right? We'll take this over to the next page. 2, 3, 24, y'all remind me what it says. 2, 3, 24. And what was the bottom one? 4, negative 5, and 20. One thing I could do is I could take row 1 and multiply it by 1/2, and that's going to give me new row 1. And that's going to be 1, 3/2, and 24/2, which is what? 12. 4, negative 5, 20. And now I'm going to take row 1, multiply by negative 4, add it to row 2 to get new row 2. Okay, so I'm going to take row 1. That's going to give me a negative 4. And a negative what? Negative. The 4 will cancel with the 2, right? Negative 6. Thank you. Negative 6. And negative 48. I'm going to add it to row 2, which is 4, negative 5, and 20. That's going to give me 0, negative 11, and negative 48 plus 20 is negative 28. And that's my new row 2. It goes right here. So that's going to give me 0, negative 11, and negative 28. Now I want to get a 1 right here, so I'm going to multiply by 1 over 11. So new, or row 2, multiplied by 1 over 11, negative 1 over 11, and that's going to give me new row 2. So that'll give me a 1 right here. And negative 28 over negative 11 is 28 over 11. And now I just got to get a 0 right here, which means I'm going to take row 2, multiply by negative 3/2, and add it to row 1 to get new row 1. So row 2 minus 3/2 is 0, minus 3/2, and that's going to be 28, be 14, be, I'm thinking out loud, just hold on. So 14 times 3 is 52, right, or 42. Be negative 42 over 11. And then 1, 3/2, and 12. 12 times 11 is 120. 120 plus 11 is 131. So that's going to be 131 over 11. No. Or will it? Yeah, 12. Yeah, 131 over 11. Multiply 11 times 12 for me. What do you get?
132.
Is 132?
Yeah.
All right. So that's going to give you 1, 0, and negative 42 plus 132 is 90, isn't it?
Yeah.
90 over 11. So that's going to give you new row 1. Which is equal to 1, 0, and 90 over 11. So this says x is equal to 90 over 11, and y is equal to 28 11ths. And that's called elementary row operations. And the elementary row operations produces the identity matrix, which is this matrix right here. Okay? That's where we're heading Thursday. Okay? So, be ready. I'll take it slow, don't worry. Let me get the roll.